Hello everyone, I am a Maker Education Trainer from DF Robot. It's a pleasure to be here today to explore our latest development board, UNIHIKER, with all of you. Before we dive into our training, please visit mindplus.cc to download and install the software as soon as possible, so you can follow along with our learning progress. Okay, next, let's delve into what UNIHIKER can do via a short video. If you haven't finished installing the software, you can use this time to do so.
Introducing UNIHIKER. A single board computer brings brand new experience. Featuring a 2.8-inch touchscreen, UNIHIKER enables you to visualize sensor data in charts, graphs, and even dynamic animations. Getting started with UNIHIKER is straightforward. Connect it with a Type-C cable, enter the displayed IP, and start programming in the browser. UNIHIKER runs on a Debian-based system. You can use various software on it just like any other Linux computer, including the built-in Jupyter notebook for web-based programming. Our hardware control library enables direct control of hundreds of sensors and actuators using Python. The built-in IoT service on UNIHIKER allows you to store data through the MQTT protocol and provides real-time data access via web browser. All the data is stored on device. UNIHIKER can connect to a router and be programmed from a computer, an iPad, or even a phone. It also supports hotspot. You can play it from anywhere. With a standard USB camera, you can apply the OpenCV library for facial recognition. Apart from Jupyter, popular software like VS Code, VIM, and Thonny can also be used for coding. You can control UNIHIKER using MindPlus and easily build projects by drag and drop, such as detecting indoor carbon dioxide levels, or even creating a game. Using Node-RED, you can also achieve automated control with UNIHIKER. On the screen, you can instantly obtain sensor data, such as laser array. No programming experience? No worries. Directly generate and debug Python code with ChatGPT. Mix and match various control and programming methods to boost your creativity with UNIHIKER. UNIHIKER controls fast open-source hardware via its rich interfaces. Using UNIHIKER, you can create a smart speaker that acts as the central control hub for your smart home system, effortlessly managing your smart home devices. Integrate it with robots' full AI brains, or transform it into a portable instrument for data exploration and observation. Compact, feature-rich, and user-friendly, UNIHIKER offers an innovative development experience for learning, coding, and creating. Unleash your imagination and embrace a new journey with UNIHIKER.
I hope the video gave you a deeper understanding of what kind of projects can be created and in what scenarios this main control board can be used. As you can see, this main board is quite powerful, especially once you understand its features. From the diagram, you can see that it comes with built-in buttons and a wide range of common sensors, including a sound sensor, or what we often call a microphone, a light sensor, and more. It also offers Wi-Fi and Bluetooth functions. Besides these, what really stands out is its large touch screen. Looking at the back of the board, it features practical tools like an accelerometer and a buzzer. Moreover, in addition to the I2C interface, it has multiple I/O ports, allowing us to connect various sensors and other hardware to enhance our creations. There's also a USB interface and an SD card slot. The most striking feature is undoubtedly the large full-color LCD touchscreen on the front. This screen opens up a world of creative teaching possibilities, from data visualization to displaying animations, appreciating famous paintings, or even learning Chinese characters. As you can see, even just with this main board, there are countless creative possibilities. UNIHIKER brings a whole new dimension to our teaching and creative efforts. And that's not even mentioning the vast range of open-source hardware that can be connected to it. Thanks to its straightforward operation and a rich programming environment, we can rapidly create even more engaging works. Today, we will be using the Mind Plus programming platform to learn how to create exciting projects with UNIHIKER through visual programming. Next, please open the Mind Plus programming software by double-clicking it. You'll notice 3 different programming modes in the upper right corner of the interface. Today, we'll be using Python mode. So, for the first step, please click on the Python icon in the upper right corner. After successfully switching to Python mode, click on Blocks in the upper left corner. We'll be writing our program using graphical programming mode within Python. Once you've done this, your interface should match the one labeled as 3 on my presentation slide. Now, let's get familiar with this interface. The topmost part of the interface is our menu bar, where we can save our program and connect hardware. The left side of the interface is our command area, where we select all our graphical programming commands. At the bottom of the command area, there's an extension button. By clicking it, we can add more open-source hardware graphical programming modules. The central area is where we write our program. You'll see a preset code there, please don't delete it. If you accidentally delete it, don't worry. There are some round buttons in the lower right corner of the programming area. They can help us undo mistakes and zoom in and out of the programming instructions. At the top right is a small toolbar, which we'll use later. The large area in the upper right is where Python code is automatically generated. The lower right corner is our terminal area. I trust that you now have a basic understanding of the entire programming interface. We'll continue to explore it as we proceed. Next, please take out your UNIHIKER and connect it to your computer using a USB cable. Once connected, you'll see your screen light up. Wait a moment until the screen displays its logo and the word UNIHIKER. Then, we can connect it to the software. After connecting the hardware, the displayed logo indicates that UNIHIKER is ready. For the next step, click the extension button in the lower left corner of the programming interface. Then click on UNIHIKER. After that, click on the upper left corner to return to the main interface. Now, you should see the UNIHIKER icon and its graphical programming instructions at the bottom of the command area. Finally, click on the Connect button in the menu bar. You should see 10.1.2.3, which is its IP address. Click on it. A pop-up window indicating a successful connection will appear on the screen. Now, our UNIHIKER and Mind Plus are connected. Now that we're connected, let's dive into learning about the UNIHIKER projects. Firstly, we'll cover the basics of screen programming and operation. How do we display text on the UNIHIKER screen? This is a fundamental skill we must master when creating projects that use the screen. For example, if I want to display the name of the main board, I can accomplish this with just 3 programming commands. Let's try it together. Go back to Mind Plus. Click on the UNIHIKER icon on the left side of the interface. You'll see that all the programming commands under the first subheading in this area are for controlling screen display. The first command is the module we use to display text. Click to select it, then drag it into the programming area. Place it between the start and loop of the main program. Release the mouse, and the module will automatically connect between the 2 modules. Next, let's check if UNIHIKER is properly connected. If it shows 10.1.2.3, we can click on Run in the toolbar in the upper right corner of the interface to see the effect of this program. As you can see, with this module, we can set the content of the text we want to display, the position of the text, and the font size and color. But before adjusting, we must understand the coordinate setting rules of this screen. As you can see, the screen's origin is by default the top left corner, at coordinates 0 and 0. The x-axis extends to a maximum of 240. The y-axis extends to a maximum of 320. If we want to adjust the position of the text, we need to increase or decrease its x or y values. Next, I'll give everyone about 2 minutes to try this out. Try to display the word hello on your own UNIHIKER with the same color, size, and position. In fact, there are 2 different ways to achieve this effect. The first way is to adjust the programming command we used earlier. Since we just learned that it uses the top left corner of this line of text as the origin, we need to adjust the coordinates of the top left corner of this text. From this diagram, we can see that it is roughly at position 60 and 120. Set the font size to 30. Then change the color to red. But in complex projects, we can take the second approach, which is to change the symmetry point of the whole hello object from the top left corner to the center. In this way, we directly position the coordinates in the center of the screen, and the text will be displayed directly in the center. This is more in line with our usage habits. Of course, this depends on the complexity of your project. Sometimes when we need to display multiple different objects, we might need to adjust it to this kind of symmetry. This makes it easier to set coordinates quickly. Here we will use a module that sets its symmetry to the center. Now I'll switch the screen back to the programming software. In the instruction module area of the UNIHIKER, we scroll down slowly, and we'll find such a module. We place it below the first module. Here we keep this forever module mainly because the encapsulation of the graphical module requires us to keep this module for code integrity. That is, we must have a while true to ensure the program is running, otherwise it might only display once and then end. But for adjustment and update, we need to name this object. You can name it anything. Here, we simply name it a. The names of created and updated objects correspond one-to-one. We need to inform the main board which object you're updating. We need to let the main board understand what the name of this object is. When you click Run, you'll find that hello appears at the position 0, 0, but since it's displayed from the center, only a quarter of it is shown on the screen. This allows us to quickly locate the center of the screen and place the object in the middle. In the same way, after creating a new object, we first need to name it. This way, if you want to adjust any of its states in the future, we can tell the computer which specific value of which object needs to be adjusted. I believe this basic programming rule is very familiar to many teachers. Just because they've turned into these blocks of programming bricks, we need to familiarize ourselves with their usage rules again. Next, you can consolidate what we've just learned based on the small challenge below. In fact, to achieve this effect is very simple. Once you've named the object, we can directly adjust it repeatedly using the modules we just introduced. This is our reference program, which may be slightly different from yours. After creating this text display object outside the loop, we only need to update it repeatedly in the loop to achieve the effect of displaying different texts at the same position, while maintaining the same position, size, and color. Next, the project effect we want to achieve is to make a small ornament that can be placed on your desktop. It can not only tell you today's date, display cute expressions, but also show a sentence that encourages you. Before making it, we can first analyze how many different objects need to be created to make such a work. In this interface, we need an object to display the date. Another one to display cute expressions. Of course, this dynamic expression is built into UNIHIKER, and teachers can find this module in the programming instruction area. Finally, there's our phrase, "Have a nice day." The text content, including punctuation, needs to be set in 5 different colors, which means we need to set up 5 different objects to set their parameters separately. Then, please try to complete this project on your own in a few minutes. Based on completing this project, you can also add your own creativity. Alright, this is our final reference program, which is actually very simple. In this project, since the only item that needs to be changed is the middle cute expression, I only named this object. I believe everyone's programming methods may be slightly different from mine, but that's okay. Once we're proficient in using it, we can find the most suitable way to write it. After you've finished writing the program, you can save this project program by clicking on the project in the top left corner of the interface. We warmly welcome everyone to share your unique creativity with us. The little assistant we made today is relatively simple, as we mainly wanted to familiarize ourselves with the display operations on the screen. In addition, if you want to review or create more interesting projects, I will provide some reference website links. You can learn in detail how to use each module, including if you want to add some touch buttons, or draw on the screen, etc. We can learn in detail through these posts. Even through this post, you can try to connect to the API, so that your local weather can be updated and displayed on your UNIHIKER screen in real time through the internet.